Have you ever had a moment where reality felt thin? You walk into a room and forget why you're there. You see a stranger who looks identical to someone you passed 3 minutes ago. Usually we ignore it. We call it déjà vu. We call it a coincidence. But in the last decade, a new term has entered our vocabulary, a glitch in the matrix. It started as a joke on internet forums, but it points to a terrifying scientific possibility. What if that feeling isn't a brain malfunction? What if it's a rendering error? To understand this, we don't need to look at the stars. We need to look at our video games. In 1972, we had Pong, two white rectangles and a dot bouncing on a black screen. It was primitive. It was barely a simulation. Fast forward just 50 years. Today, we have Unreal Engine 5. We have photorealistic worlds, ray-traced lighting, and physics engines that mimic gravity and fluid dynamics. We have virtual reality headsets that trick the human inner ear. This rate of progress is not linear. It is exponential. If you assume any rate of improvement at all, even a slow one, then in 1,000 years or 10,000 years, our simulations will become indistinguishable from reality. And that leads us to the ultimate question. A question that keeps billionaires like Elon Musk and astrophysicists like Neil deGrasse Tyson awake at night. If it is possible to create a universe inside a computer, and if civilizations survive long enough to do it, then they won't just make one. They will make billions. Billions of history simulations. Billions of ancestry simulations. So, do the math. If there is one base reality and billions of simulated realities, what are the odds that you, right now, are in the one true original world? The odds are not in your favor. In fact, statistically speaking, the chance that you exist in flesh and blood is close to zero. You are likely just code, processing data in a server farm the size of a galaxy. Welcome to the simulation hypothesis. Today, we are going to look for the evidence. We are going to test the walls of our cage. This idea feels modern. It feels like it belongs to the age of Silicon Valley and AI. But humans have suspected that reality is a lie for thousands of years. The terminology changes, but the paranoia remains exactly the same. 2,400 years ago, the philosopher Plato wrote The Republic. He asked us to imagine prisoners chained inside a dark cave, facing a blank wall. Behind them is a fire. Puppeteers walk behind the prisoners, holding up objects that cast shadows on the wall. To the prisoners, the shadows are reality. They give them names. They study their movements. If you told them there was a 3D world outside the cave, they wouldn't believe you. They would call you crazy. Plato was arguing that our physical world is just a shadow of a higher truth. Fast forward to the 17th century. René Descartes, the father of modern philosophy, stripped away everything he knew. He asked, "How do I know I'm not dreaming?" He proposed a thought experiment. What if there is no God? What if there is an evil demon, a powerful, deceitful entity dedicated to tricking my senses? The heat of the fire, the wood of the desk, all illusions fed directly into the mind. In the East, this is known as Maya in Hindu philosophy, the grand illusion that masks the divine reality. The concept that the material world is a stage, a drama, a play meant to be experienced but not believed. But in the 20th century, the evil demon was replaced by the supercomputer. Science fiction writers like Philip K. Dick began to see technology as the new creator of illusions. In 1977, years before the Matrix was even a concept, Dick stood in front of a confused audience in France and said, "We are living in a computer-programmed reality, and the only clue we have to it is when some variable is changed and some alteration in our reality occurs." He was laughed at. he was dismissed as paranoid. But today, physicists are finding code in the fabric of space-time. The evil demon has become the system administrator. So, how do we move from philosophy to hard science? It starts with a simple paper published in 2003 by an Oxford philosopher. A paper that changed the way we look at existence forever. The year was 2003. While the world was distracted by geopolitical chaos, a Swedish philosopher named Nick Bostrom published a paper in the Philosophical Quarterly. It was titled, "Are You Living in a Computer Simulation?" Bostrom didn't rely on science fiction. He used probability. He proposed a trilemma, 3 logical gates. He argued that one of these 3 propositions must be true. Not might be true, must be true. Proposition 1. Humans go extinct before we reach a post-human stage. We destroy ourselves with nuclear war, climate change, or AI before we ever have the computing power to run realistic simulations. Proposition 2. We survive, we become post-human, but we have zero interest in simulating the past. Perhaps it's illegal. Perhaps it's considered unethical to create conscious beings just to watch them suffer. But if, and this is a big if, we don't go extinct and we do have the interest, then we are left with Proposition 3. We will create simulations. Think about it. Why read a static history book about the 21st century when you can run it? Future scholars could simulate their own ancestors, us, to understand how sociology works, how wars start, or to simply experience the lives of their predecessors. It is the ultimate history lesson. And because computers can run 24/7, one advanced civilization could run millions of ancestry simulations simultaneously. This creates a staggering statistical ratio. Imagine a bag with 1 red marble and 1 billion blue marbles. The red marble is base reality, the real world. The blue marbles are the simulations. If you reach into the bag and pull out a marble, your life, what color is it likely to be? Unless you believe we are the very first civilization to ever exist in the history of the cosmos, the math dictates that you are almost certainly holding a blue marble. Bostrom argues that believing you are real is actually the arrogant assumption. It assumes we are the special ones, the Category 1 beings. So the logic is sound, but logic isn't physics. Just because something is probable doesn't mean it's possible. Can you actually build a computer powerful enough to fake a universe? Critics of the simulation theory often point to complexity. They say, to simulate every atom, every electron, and every quark in the universe would require a computer bigger than the universe itself. And they are right. If you tried to simulate the entire cosmos at once, it would crash the system. But here is the secret. Video games don't do that. And neither would the simulator. It's called optimization. In computer graphics, we use a technique called frustum culling or lazy loading. The computer only renders what the player is currently looking at. When you play Grand Theft Auto, the city behind your back doesn't exist. It is just data on a hard drive. It only becomes real the moment you turn the camera. Applying this to our universe solves the computing problem. The simulation doesn't need to render every atom in a distant galaxy. It only needs to render a blurry image of a galaxy when an astronomer points a telescope at it. It explains the Fermi paradox, why the universe feels so empty, why render billions of alien civilizations if the players, us, can't reach them yet. It's a waste of RAM. This suggests that reality is on demand. Things only exist when observed. And shockingly, this isn't just a metaphor for coding. This is exactly what quantum mechanics has been telling us for 100 years. But how much power would we really need? Enter the Matryoshka brain, a theoretical megastructure that captures 100% of a star's energy to power a computer. A computer of that size could simulate the entire history of human thought in a millisecond. We are worried about battery life. They are playing with the energy of suns. So, the logic holds up. The computing power is theoretically possible. But is there any physical proof? Is there a glitch we can measure? The answer lies in the smallest pixel of our reality. To find the glitch, we have to look at the behavior of light. In the early 1800s, physics was simple. We thought we knew how matter worked. But then came the double-slit experiment, the experiment that broke reality. Here is the simplified version. If you shoot marbles at a wall with two slits, they form two bands on the back screen. Simple. But if you shoot electrons, tiny bits of matter, they don't form two bands. They form an interference pattern, a wave pattern. This means that matter, at its core, exists as a wave of possibility. It is not here or there. It is everywhere at once. It is in a state of superposition. But here is the terrifying part. If you place a detector, a camera, at the slits to watch which hole the electron goes through, the wave stops. It instantly behaves like a solid particle again. Think about that. The mere act of observation changes reality. It's as if the universe is saying, "Oh, you're looking? Let me quickly decide where this particle actually is." In a video game, the computer doesn't render the loot inside a treasure chest until you open it. It saves processing power by keeping the contents in a state of probability. Physicist Tom Campbell argues, this is the rendering engine of our reality. The universe is optimized. It doesn't calculate reality until a conscious mind requests the data. This solves the biggest mystery in quantum mechanics. Why is the world so weird at the microscale? Because that's the code layer. That is where the simulation cuts corners. Einstein hated this. He famously said, "God does not play dice with the universe." But the evidence suggests that not only does God play dice, the dice are loaded. If quantum mechanics is the software optimization, then what is the hardware limit? How small are the pixels on your screen? If our universe were real and analog, you should be able to divide space infinitely. Half a meter, half a millimeter, half an atom. You should be able to zoom in forever, but you can't. Physics tells us there is a hard limit, a brick wall at the bottom of reality. It is called the Planck length. It is 1.6 times 10 to the power of negative 35 meters. It is so small that if a proton were the size of a galaxy, the Planck length would be the size of a Tokyo subway ticket. According to quantum gravity, you cannot measure anything smaller than this. Space is not smooth. Space is discrete. It is a grid, a 3D lattice of information. Why does the universe have a minimum resolution? In a computer, resolution is limited by memory. You cannot have infinite detail. The Planck length looks suspiciously like the grid size of our simulation. But the evidence gets weirder. Dr. James Gates, a theoretical physicist who works on string theory, found something impossible in his equations. Deep inside the supersymmetry equations that describe the fabric of our universe, he found repeating sequences of code. Specifically, doubly even self-dual linear binary error-correcting block codes. That's a mouthful, but here is what it means. It's the exact same code Claude Shannon invented in the 1940s to stop data from getting corrupted over telephone lines. It's browser code. Why would the fundamental laws of physics contain computer code designed to fix transmission errors? Unless reality is a transmission. We have found the pixels. We have found the error-correcting code. Now let's look at the user settings, the fine-tuned constants that keep us alive. If you were designing a video game, you would need to set the rules. How high does a character jump? How fast does a bullet fly? In physics, we call these the universal constants. There are about 30 of these numbers. The strength of gravity, the mass of an electron, the expansion rate of the universe. Physicists have noticed something disturbing about them. They are perfect. It is called the Goldilocks effect. If the strong nuclear force were just 2% stronger, stars would burn out in seconds. If it were 2% weaker, atoms wouldn't stick together. In either case, life is impossible. Sir Martin Rees, the astronomer royal, compares it to a firing squad. Imagine you are facing 50 marksmen. They all fire. They all miss. Would you say, wow, what a lucky coincidence? Or would you suspect the whole thing was rigged? The anthropic principle suggests the universe was customized for us. In a simulation, this makes perfect sense. These are variables. When a programmer builds a world, they tweak the settings until the system is stable. If the simulation crashes, they restart. They adjust the gravity. They run it again. We might be living in version 10,000. All the previous universes failed. We are the successful build, the release candidate. But there is one thing code cannot easily explain. One thing that separates us from a calculator. The feeling of the sun on your face. The taste of coffee. We are now facing the biggest counterargument to the simulation theory. It's not about physics. It's about the mind. Can a computer program truly feel pain? Or are we just sophisticated biological robots fooling ourselves? In philosophy, this is called the hard problem of consciousness. It's easy to explain how the brain processes data. Input, fire. Output, pull hand away. That is mechanics. But why does it hurt? Why is there an inner movie playing inside your head? If we are simulations, there are two possibilities for who or what we are. Possibility 1, we are player characters. We are conscious minds from the base reality plugged into this VR game, like the Matrix or Avatar. In this scenario, your body is fake, but your soul is real. You are a tourist in a digital theme park. The higher self is just you holding the controller. Possibility 2 is darker. We are non-playable characters or NPCs. We are part of the code. We don't actually have free will. We just run complex behavioral scripts that feel like free will. Philosophers call this the philosophical zombie, a being that looks human, acts human, screams when you hit it, but has no inner light. If AI continues to advance, we will soon create NPCs in games that beg for their lives. They will say, "Please don't turn me off. I'm scared." Will that be real fear, or just a line of code executing a fear response? And the most haunting question, what is the difference between you and that AI? Perhaps consciousness isn't magic. Perhaps it is just what data feels like when it is being processed in highly complex loops. If we are NPCs, does our life matter less? Or does it matter more because we are the universe's way of thinking about itself? Now, let's confront the final implication, the ethics of the creators. If we accept the possibility of a simulation, we must ask the final uncomfortable question. Who is running this server? In religion, we call him God. In this theory, we call him the user. Are they benevolent creators? Or are they a post-human teenager playing The Sims on a Saturday night? If they get bored, do they cause a tsunami just to see how the AI reacts? This introduces a new kind of existential dread. We are not afraid of hell. We are afraid of the off switch. We are afraid of the blue screen of death. But there is a more optimistic view. Maybe this isn't a game. Maybe it is a diagnostic tool. Perhaps the base reality is dying, ravaged by climate change or war. They might be simulating the 21st century billions of times to find a solution. We might be the calculation that saves them. Our history is their textbook. This implies that our choices do matter. If we destroy ourselves in the simulation, The data is useless. If we survive, we win the game. It also changes how we view death. In a computer, code is rarely deleted, it is archived. Perhaps death is just logging out. Perhaps you wake up in an arcade, holding a ticket that says score, 85 years. So are we real? The math says no. The physics implies we are pixels. The logic suggests we are code. But does it actually matter? If you feel pain, the pain is real. If you love someone, the love is real. Real is not about what you are made of. It is about what you experience. Even if the universe is a simulation, it is the only one we have. The graphics are incredible. The plot is unpredictable. And the gameplay is entirely up to you. Maybe the goal isn't to hack the system or escape the matrix. Maybe the goal is simply to play. Now, I want to turn this question over to you. If a red pill appeared on your desk tomorrow, offering you the chance to wake up and leave this simulation forever, would you take it? Or is the game we are playing here worth staying for? Let me know your answer in the comments below. I read the most thoughtful ones. If you found value in this investigation and want to support high-quality, objective storytelling, please consider subscribing to Stratum Logic. It helps us continue to ask the hard questions. You can also click here to watch our previous documentary on the Great Filter, which asks why the universe is so quiet. Thank you for deep thinking with us.